Okay. Welcome everyone to today's meeting. Very happy to announce that today is a joint meeting with ACI. We're teaming up with them today. So welcome, in addition to the CEOS members, any ACI members that have joined us. Thank you for joining. We have some chapter announcements to start off with. April 7th, we have the Young Professionals, the Young Members Forum is putting on a webinar about financial planning. Zachary McDougall is a well-known figure in this space, and Kyle Standaffer, also an associate financial advisor that works with Zachary, are presenting a talk on personal finance targeted to engineering professionals and their families. Very good information, especially as it is specific to people in our field. So highly recommend getting on our website and signing up for that if you're interested at all. Next, our April 20th, so our next webinar, our next luncheon meeting, it's a joint webinar with EERI, and the topic is going to be seismic instrumentation. We'll have representatives, a representative from OSHPD and one representative from the city of San Diego. We'll talk about their specific requirements, the history, how they interpret and enforce the seismic instrumentation programs within each of those departments. That'll be very practical and very informative as well. And we are officially calling for nominations for the Excellence in Structural Engineering Awards 2021. So all you engineers out there, start thinking about this and putting together some nice presentations for your amazing projects. And then lastly, for CEOS, May 10th, we have our golf tournament. That's coming along very nicely. This is going to be real live golf played on a golf course. And so save the date, May 10th. We're looking forward to getting out and seeing people we haven't seen in a very long time and playing some golf. So registration for that is open as well, I believe. Casey, take it away.
Cool, thank you. Again, welcome everybody for our ACI San Diego chapter. This is our first shot at a lunch or a webinar. So just kind of off the topic, but if you guys want to send us any of your feedback, we would appreciate that too. First off, I want to thank our sponsor for today, Udilite Corporation. Appreciate you guys sponsoring this event for us and your continued support. So a couple announcements on our end. Our next webinar, our first solo webinar, will be on April 13th. You've seen the emails come out. The topic will be the future of fly ash supply, which is a topic that's very near and dear to all of us in concrete here in San Diego, especially of late. Speaker will be Thomas H. Adams, who's the executive director of the American Coal Ash Association. He's going to be talking primarily about fly ash overall throughout the U.S., but obviously, seeing as how our fly ash doesn't come from California, it comes from a lot of other places, it's going to be very applicable to us. Talking about the new sources and just kind of where that market is heading in the upcoming years. So if you're interested in that topic, sign up. There should be another email blast going out this week that you can click to register. Also, we are taking ballots for the 2021-2022 board. The ballots will be out in your email soon for voting. We got 4 new trustees and 1 returning, I believe, that are up for consideration, as well as your new executive board members. It's been a fun 2 years of presidency for me. I do not plan on staying on for the next year, so it would be great if you can show your support to the people who are prospective coming into the board. And you should see that email coming out here in the very near future as well. And then also you should see an email coming out for scholarships. They're open for entries. I don't believe we have many entries yet so far. So if there are any students on right now, make sure you sign up and apply for the free money. That's it for ACI San Diego. So back to you.
All right. Thanks, Casey. So we're ready for our presentation today. The topic will be the new ACI 301-20 specifications for concrete construction. And before we start, I just want to let you guys know that if there are any questions that come up, please type those in, enter those in the team's comment sidebar. And we'll take questions after the talk. But to introduce our speaker, we are very grateful and honored to have Michelle Wilson with us today. Michelle is the Senior Director of Cement and Concrete Technology at the Portland Cement Association. She's a member of ACI's Board of Direction, a fellow of the Institute of ACI, and served as chair of ACI Committee 301, the specifications for structural concrete, during the 2016 to 2020 cycle. Michelle is a member of ASTM International Committee C09 and serves on that executive committee as well. So again, a big round of applause for Michelle, and thank you very much, Michelle, for being here with us, and take it away.
Well, thank you for that lovely introduction. I appreciate you guys inviting me to present today on the ACI 301-20. It is fresh off the press as of October 2020, and it is a complete renovation of the document. And when I say that, of course, existing content from the 2016 document remains, but I do want to highlight many of the changes and many of the requirements that stayed. We won't cover today, but if you have questions on that, I'd be happy to handle them in the Q&A after. ACI published 301-20 specifications for concrete construction in October, and it's a standard spec. I hope everyone understands how ACI works. This is a standard that is meant to be a default criteria for your documents. It's more to cover anything that is general concrete construction and special applications, but if there's something specific to your project, obviously you need to overwrite this document. And there's many other things that are in ACI 301 that are open-ended, and this is important to the designers and the contractors as to how to use this document. So we'll get into that today. So what I want to cover today is what are really goals of specification, and what are the ACI standards and codes that are related to 301, and then how to properly reference ACI 301. Okay. So the goal of any specification, and it doesn't matter if you wrote it or if it's a cookie cutter from days gone by, you need to really rehash those and make sure they're up to date. The goal is that they are clear. We don't want to get other people involved that don't need to be. We also want to make sure that there's only one single interpretation of the meaning of the sentence or the optional requirements, and that it's written in mandatory language. There's a lot of documents out there that give guidance. I happen to be somebody who does quite a bit of those types of resources for our industry. They are not mandatory. They are guidance. They are industry standards, or I should say they're state-of-the-art guides, and they're meant to give you guidance on doing a specification correctly. But this mandatory terse language is for codes and standards that is legal and cannot be misunderstood. And so we'll get into a bit of that as to why it's important to us. There is a lot of confusion in specifications as to what complies and what is important in your defaults. So speaking of defaults, do you know them? Are you aware of all the standards that are out there in ACI? And there are volumes of them depending on what you design or construct in our industry. So most people are aware that the majority of ACI documents default to the content that is within ACI 318. And 301 is similar to that. We follow what is in the building code, but we also go beyond the scope of a 318 building commentary. And It also defaults, remember, it is the specification from the designer to the contractor, but there are also companion specifications out there, such as ACI 311.6, which is the spec between the ready-mix, for the testing services and the owner. And also ACI 117 is mentioned in 301, and those tolerances are brought into 301, but there are tolerances within 301 that 117 doesn't cover. So that's something to consider as well. And then, of course, ASTM standards are part of this as well, and that includes things like ASTM C94, the specs for ready-mix concrete. So all of these are basically a big envelope that we must follow. And 301 is written to comply with 318, Chapter 26. If you're not familiar with the reorg from the 2019 document, you really need to get used to it. They've rearranged everything where Chapter 26 is the construction requirements, and the compliance details within 301 have been updated to be aligned with 318.19. So most of these changes were included to reflect changes in the 2019 318, and we'll cover some of those today. There are some current changes. What do I mean by umbrella? I think it's important to understand that each of these documents pretty much references the others. So there's a lot of intertwinedness, and making sure that they harmonize, making sure that they state what you want in your specification is important. And it's also very important that you don't specify a code in a specification. That's the designers using the code, unless you plan to design something such as post-tension concrete or formwork. You might be specifying another type of document that is a design standard. But if you're writing to the contractor, you're telling them what they need to know. So it's important that you have that information. And also it's important to remember ACI isn't actually a building code unless your state adopts it. So California, has adopted through the IBC, but it's also important to look up the year that they've adopted. And I will be honest, I didn't do my homework. So you'll have to tell me when we get to the Q&A as to what year you guys are on, because it's really important for making sure that we are using current materials, current guidance, and there's reasons why these standards evolve. So that's very important to us. Speaking of evolving, 301 has evolved over many years. Approximately every 5 years, we update this standard, and we're trying to meet the 318 cycle as about a year behind them, maybe 6 months, depending on timing. And that goal is because obviously we want to incorporate their changes into our document. And this is a standard that is reviewed by a technical activities committee as well as put out for public comment so that it can be used in contract documents. I've been on the committee for approximately 20 plus years. I don't want to age myself too much, and served for secretary from the 2010 to the 2016 cycle, and just stepped down as chair in 2020. I've seen a lot of change in scope. I've seen quite a bit of improvement in formerly prescriptive requirements that no longer need to be that way. We're not making a box that meets everything. We are trying to make very innovative concrete structures that need specific requirements that might be performance-based. So it has become a contractor-friendly document, but also has safeguards to make sure that the structure and application holds up. It is a consensus. So how 301 and ACI works, for those of you who aren't members of ACI, and I hope most of you are, designers, concrete producers, material suppliers, builders, and we do have academics as well, and of course a few trade associations such as myself. And prior to COVID, we would sit in a meeting room for 3 days straight for about 6-hour stints to get these ballots handled and any negatives, and get the content brought forth for changing the language in the document. There's strong opinions from various sides, but it's a very balanced committee as ANSI standards require. And what I found being a member of the committee and also as a leader of it is that if everyone is equally unhappy, we're doing it right. Consensus means you're not coming up with necessarily a number from one side of the fence. You're finding some sort of consolation at times. So it may not satisfy a certain side. It's satisfying the concrete. The important part is that the concrete turns out. But I don't want to say that we weren't a fun committee. There were some very hardworking, very smart leaders in our industry on the committee that it was a joy to have such strong brains putting forth the information. But we also tried to have fun. Pre-COVID, we would get together after every convention and spend some quality time in a nearby location. And since then, we've had a few virtual, but we brewed our own beer and had some fun. So it's not all work, it's a little play too. But while we are working, we are following the master format guide. So 301 is set up to work with most architects and engineers' office documents, which typically follow the Construction Specifications Institute standard of a general section, a product section, and an execution. If your documents don't follow that, you probably need to look at them a little closer unless you're a different type of entity, which we can talk about during the Q&A. But remember that CSI has over 50 divisions, and only one of them is cast in place concrete, and of course they have precast as well. And ACI it covers many different special applications of concrete, and of course 301's one specification for concrete for ACI. They do have some very specialized specifications as well that are not within the scope of 301. So how does 301 work as a contract document? It's really important that you all get a copy of it. It's 60 pages long, but only 53 pages of it are the legal document, which we would call the body of the specification. That's the language that gives direct instructions to the contractor. But there's also a really important part of 301 that many people aren't aware of. This isn't a closed document. This is a default specification where the designer has to make decisions, just as you would if you worked with 318 and many others. So there are directions to the specifier in the back pages of the document. We call those checklists. And there's mandatory requirements to review, and there are optional requirements to review. And those are very important to look over. We'll get to them. Now, within the main body, the first 5 sections could complete your structure depending on what you're building. They include your general requirements, which have your testing and your references and other important requirements within the specification, such as definitions. And then it continues with formwork, reinforcement, concrete mixtures, and handling and placing. So there are many other sections within 301, and those are what we call optional sections. It has to be determined that your project has this work on it, and that is up to the specifier to determine that and designate it on the project as to which portions of the project are, for instance, architectural concrete or mass concrete or precast architectural, and then suddenly that section would become mandatory within your document. So that's an important part. So within these checklists, there are a lot of different decisions to make. In the mandatory checklist, you have a lot of notes to the specifier that you have to decide, for instance, which sections you're going to use. You have to define strength of your concrete. It's the trigger language that will help you with that, but really just review the checklist and then go back to each section and look for things like as specified in the contract documents, unless otherwise specified will get you to the optional checklist. So, the information you would think of that you need to make decisions on, the common information would be things like specified strength, maximum aggregate size, tolerances that are outside of 117. But the really important part as well is to make sure that you're designating any specialty sections within your scope as well. And then on the other side is the options, and that trigger language is when it says something like, unless otherwise specified or required. Then you go to the optional checklist and make a decision as to what alternatives there will become mandatory requirements in the document. Okay, so that's an overview of the way that we've constructed 301, and it's been that way for many years. It's the way ACI does specifications, and it's really important for designers to know it's an open spec. I will say that over and over in case you're not listening. But we've made changes. So what's new? Well, the title. the title has changed. Why we changed it was really important. We talked about it from last cycle. I'm not sure how many different standards you guys work on, but the why are you here, what's your purpose, what's your mission, are always important. So scope is important. And there were a lot of people that thought 301 should only be the specification for 318's scope. And there were many other people who felt there were reasons to include other content in it. And another example of that would be improving the scope to include the breadth of the document, such as industrial floor slabs and architectural concrete, which are not 318 concrete. So we changed the title to be more clear on that, and it is now specifications for concrete construction. So that was a bravo change to try and avoid confusion of our scope, which you can find in section 1. Another thing we did to avoid confusion, or perhaps to avoid lawsuits, was that we cleaned up a lot of the definitions. Definitions can be a point of contention. Definitions can make you designate work you probably don't have, or maybe you do have, and you're looking at the definition and interpreting it differently. So to avoid that, we've removed the designations for portions of work, even though many of us would probably agree what is architectural concrete. Exposed to view can become a day-long conversation. Also, it's important that we properly designate what is the responsibility of the contractor. So another change in the document that I think has been a great improvement, and surprising that it took till the 2020 document, is there's now an optional requirement for pre-construction conference. There was a bid to make it a mandatory, but I'm not sure why that became such a big deal. But this is within the optional checklist to make to designate for a pre-construction conference, and it tells you what types of criteria you have to meet and who needs to show up. You can't make people come to a meeting, as we all know, especially in a virtual world, but it's important to cover this information. We've also included some new material, mostly to comply with 318.19. For instance, there is now a recycled aggregate within the document per ASTM C33. Any of you who work on ASTM standards may know that ASTM 33 updated it. Well, it updates its document every year, but there was a huge update in 2019. And that update changed the types of materials that are permitted within ASTM C33. So what that does is makes recycled aggregate permitted for use if you're not reviewing C33. So that's why it's really important to be aware of standards and not just envelope them into your documents without knowing what you're referencing. And if you do want to make any restrictions, that's suitable. So recycled aggregate has been a proven material for many years, especially in buildings, but there might be some nuances that you're concerned about for specialty structures, whether that's shrinkage, whether that's concern for ASR, that you might qualify with some pre-testing. All of these things can be done properly in a specification as long as you put the words in the document. Another thing that is now allowed in ACI 301 is mineral fillers. It's a rather new specification in ASTM C1797. And so those are within 301. They are also permitted in ACI 318, and they are about to be, so it's up for ballot, I should say. They've been balloted in ASTM C94. So once you have that envelope, you would have to consider why you don't want to use mineral fillers. And these materials can add to your mix design when you use all these new products, or I should say recycled products, properly. Okay, another thing we've done is considered the prescriptive requirements within the document. Now, I like to pretend I'm young, but I'm definitely old school at this point, but that doesn't make me a curmudgeon yet. And I'm aware of this table. It is a PCA table from many eons ago that has been folded into many ACI documents, including, for instance, the floors on ground document, which is ACI 302. It's a guide. And the goal of this document, or this table, I mean, it wasn't to design your mix for you. It was to make sure that there was enough paste for flatness tolerances. They didn't want aggregate shadowing. They wanted a densified surface. They were talking about quality of floors. And, things have evolved. We've done a lot of different things with machinery, with mechanical finishing. There's a lot of different cementitious ingredients out there and other ways to make acceptable concrete. So these numbers might not be the be all to end all for every single floor. So with that said, they had been in 301 for many years, and this table has now been removed from section 4, which is the concrete mixture requirements. However, it is still a requirement. This table does have some requirements under the industrial floor section, and the reason for that is they've been so successful in becoming prescriptive over the years that some industrial floors have had some aggregate shadowing and other issues with abrasion resistance when you get too lean on your mixtures. So that's different. But at the same time, when you spec something so prescriptive as a cementitious requirement, you've basically started the mix design and held the hands of anybody being able to have some wiggle room on what they choose to use. Okay. We also have some changes in the aggregates requirements. The timelines for pre-qualification of aggregates were extended, and data on compliance for instance, for alkali aggregate reactivity under ASTM C1293, it now needs to be within 24 months. And that makes sense if you know the test. It takes approximately a year to run the test. So if you can evolve it and cycle it, then you should have data within every 2 years if you're doing your testing correct. There are also different limitations to the mixture requirements than was in the 2016 document to qualify the mixture and reduce potential for ASR. So it doesn't just default to ASTM C1778, which is a new mitigation specification. It's really meant to be a pre-design type of specification, or you're inspecting existing concrete. So it's meant for prevention of ASR. The goal of 301 is to be able to properly test and design our mixtures up front. So there's different limits for alkali loading than there used to be. And there's different requirements on calcium levels of fly ashes and such. So I can get you that information. It's straight out of 301 in section 4. Another change in the reinforcement section was that zinc galvanized bars were updated in their requirements in 318 and now have to conform with ASTM C8767. And that was changed in the 2019 code. However, there are times you're not using rebar that needs to conform to 318. There's lots of jobs out there that have light steel or different types of steel in them that are not 318 concrete, and those may be allowed to conform to ASTM A1094, which the major difference between these two standards is a different thickness in the zinc coating. So when it comes to corrosion protection, those standards have different levels. Another new application in 301 is shotcrete. Shotcrete was added to 318.19, and they made many changes to the testing requirements and all of that in 318. How 301 handled it at this time, because we felt it was very cumbersome and could be misleading to suddenly put a bunch of upfront testing. We clearly state that if you're using shotcrete, that you need to design and construct in accordance with ACI 506, which is the specification for shotcrete. Some people really wanted to bring specific language into 301. We weren't quite there by the time we were publishing. So I think there might be some evolution of that in this next cycle. But really, if you think about shotcrete, it's just a different form of placement method. The concrete's still concrete once it's hardened. However, it is important to remember that while it's a different form of placement, there'll be different testing and acceptance criteria with shotcrete than there is with your conventional acceptance testing of concrete. And along those same lines is self-consolidating concrete, which has been in 301 since the 2016 document. It's been around for much longer than that, but there's been quite a lot of advancements on the ASTM side with self-consolidating concrete. So in the 2016 specification, the slump and slump flow requirements were kind of combined in the same paragraph and may have been misleading to an innocent user of SCC. So those were separated out for clarity. Without requiring pre-qualification of the mixtures in 301, it does give an optional requirement if specified that passing, ability, and static segregation need to conform to ASTM C1621 and 1610. So that's a good improvement to the document. There could be a lot more if you really wanted a spec specific to SCC, but I think that really covers the minimum criteria that you should have on SCC in any document. Another change in 301 is the modulus elasticity requirements. Those were never mentioned in 301, and there are a lot of tall buildings being made of concrete as a preference material. And instead of being designed by strength, they're being designed by modulus requirements. So test data may need to be pre-qualified, and then there might even be testing requirements on site as well. So this needs to be considered. And that's all new, and also a new change in 318.19. Some improvements to the document in section 5 on construction. It had in 2016 changed the surface finish requirements to a set scope of surface finish 1, 2, and 3, and had various types of defaults for requirements of amounts of allowable bug holes, those types of things, and what types of repairs were required. Now we have a default for finishes of SF2, and we've definitely clarified color, texture, and other types of finish requirements have been cleaned up so that there's not arguing over aesthetics. Now, if you are arguing over aesthetics, mock-ups are also an option for Section 5 concrete. They become a requirement in some of the other special applications, such as architectural concrete and tilt-up concrete. Speaking of tilt-up concrete, unlike surface finish that you're typically casting in a form, these are specific and could be architectural. So these are panel finishes, slightly different than the SF2. So they change and add the P to them, but it's a very similar requirement level unless you're doing architectural as well, and then you're calling in Section 6, which has much higher scope of architectural finishes. Just like in Section 5 for repair, you have to specify what level of cracking, and specs that just say no cracks allowed. It really needs to require what level of finish is allowable, what size, any type of void or anything that's allowed. So that's all stipulated in Section 6 and in Section 12 on tilt-up. And there are mock-ups required in Section 12, so that helps for tilt-up. Speaking of formwork and making sure you do get a correct finish and a good quality finish, one of the changes in formwork, we really didn't have major changes in the formwork section. We had talked out and balloted quite a bit, such as waffle forms, and we can't talk enough about chamfer, but there isn't many changes in Section 2, with the exception of we did change a requirement for the porosity level of certain types of veneer for your formwork if you're using wood formwork. And that was because the quality of certain products was changing throughout the United States depending on shortages and such. So that's something to consider. There are also new requirements in the 2020 version on adhesive anchor certification. So this is, adhesive anchors were in the 2016, but the certification program came out afterwards and is now in ACI 318.19. So if you have adhesive anchor holes that are horizontally or upward inclined, then it is required, if they're being sustained by tension, that they're installed by a personnel that is ACI certified. So that's a new change to the document. There are some other certification requirements in 301 that you should be aware of. Most of those are from previous 2016 cycles, such as PTI certification and, of course, ACI's field level certification and such. On mass concrete section, most of those changes were done in the 2016 document about a thermal control plan and differential temperature and, of course, upper temperature limit for concerns of delayed ettrinite formation, and thermal cracking is really a larger concern with mass concrete. So with that said, there were many material restrictions that were removed from mass concrete. There's a lot of people that specify mass concrete as a simple, don't let your temperature get above 70 degrees Fahrenheit and don't use type 3 cement. Well, it's 2021 and you can use all sorts of cementitious ingredients, including silica fume, because maybe you're making a thin bonded overlay, but the cement factor and the heat, which by the way, silica fume doesn't have, it's maybe going to get in the realm of giving you a need to devise a thermal control plan. So mass concrete isn't just about thickness of section, it's definitely about cement factor as well. So the spec now allows permissible changes to materials and encourages a thermal control plan to be required. So with that said, you might have some curing requirements that are within section 5. We debated certain requirements in the document, such as ACI's curing by ponding. There's been a rule of thumb in our industry for many years that ponding temperature shouldn't vary more than 20 degrees from the surface temperature. We debated that for many years. There's been a lot of research studies in ACI, and we're concerned about thermal shock. So that would be why we want to control that temperature differential. But really, the temperature differential that works for most rule of thumbs, really it's going to be specific for your project, is that 35 degree F temperature differential. So, and then we're saying that if it's ponding water, that you don't want to have cold water so that you get a thermal shock issue as well. And again, ponding is not allowed in mass concrete, so, but that was in the previous spec. Internal curing is new in ACI 301. It wasn't covered previously, so it defers to an ASTM standard, ASTM C1761. And the difference between it and some other standards is it's limited to pre-wetted fine aggregate and does not include coarse aggregate. On the cold weather curing requirements, there are some changes to the temperatures of embedded elements. For any type of metallic element coming through the concrete, we want to keep that temperature differential within 10 degrees Fahrenheit. A lot of times it would say don't allow it to be less than 32 degrees Fahrenheit, which is good for contact surface temperature of soils and such. But there's a lot of research out there, including CRSI, that shows that metals themselves, which obviously are a conductor of heat, do not need to be 32 degrees to place your concrete. So it's just something to consider as you're placing your concrete. Now, another thing that changed, and this is in the industrial floor section, is the qualifications of joint fillers. They now are very specific, saying they need to be 100% solids. They need a shore hardness of at least 85%, and that's within ASTM D2240 for a specific type. So it's upping the level of joint filler that's used in industrial floor slabs. And then we want elongations that are below 90% within ASTM D638. So all the shrinkage requirements in industrial floor slabs are within ASTM C150, and there's a few other 157, I should have said. There are a few other requirements within industrial slabs, of course, for flatness and levelness, but there weren't too many other changes because that got an overhaul in the 2010 document. There were some changes on the post-tension side as well. Those changed in ACI 318 as well. Non-encapsulated tendons are prohibited in 301, and all of these caps need to be properly, whether they're filled or not, depends on your design requirements. But we also changed some provisions on cutting of tendons. Some people were concerned about the torches and such. So it just gives it gives recommendations without telling you can or can't use certain types of old school cutting mechanisms. There are also some fabricator qualifications on the precast side that you should be aware of. There is an alternative certification program from the National Precast Concrete Association that may be allowed for your type of application of a precast, whether you're making anything structural or not. It's if it's pre-stressed, it has to follow PCI's certification program, but there's many structural products that are non-pre-stressed that can have a suitable alternative certification program. That's a quick overview of a ton of changes in 301 without getting into the nitty-gritty of the whole document, because I want you to read it. You need to open it up. You need to see what your defaults are. You need to avoid the confusion that's often in there. And I go to sleep at night worried that the only people reading 301 are lawyers. And I think we've all been to those situations where people interpreted a sentence differently than each other. We hope reference specifications cover everything for us, but without knowing what they actually say, how can you determine that? So for a designer, 301 is meant to tell you what your options are for performance. What do you really want? And then make some decisions. Remember, it's open-ended, lots of optional and lots of mandatory decisions to make. And then on the contractor side, you need to find out what you just promised by signing up for that job. And then for anyone involved, just remember there's more than one way to get the project done. And that's why we don't want to be too prescriptive in 301. It's really important to remember that this is a default specification. The proper way to reference ACI 301 in your specifications is to take the entire title. I encourage you, and it says it right up front in 301, to not take snippets of 301 or defer to specific sections of 301 because the document is meant as a whole. If you want to take a provision of 301 out, you need to write that whole thing into your spec and not even defer to 301 then. Now, there's nothing wrong in your specification with deferring to 301 properly by saying the work will comply to specifications for structural concrete published by ACI, except as modified in these contract documents. And then if you don't like something 301 says, or your job is much more particular, then you put those requirements in to override the defaults in 301. And that should make a lot of sense to all of us. And we need to know you're not done. This isn't the catch-all. You're not done until you go to the mandatory checklist and you consider the optional checklist for all the triggers and make those decisions, and then you have a closed document. Until then, you're up for a lot of trouble by defaulting to 301 without reading it. Now, maybe you think your company spec has closed all those loops, but just remember this is a 2020 document that has been updated to ACI 318.19. And so those type of construction provisions need to all be followed per code, per IBC. So that's important to us. So the real goal here is that specs need to be clear. They need to be concise. They need to have the hoops that you want for performance, and then make someone jump through them. Don't ask for more than you need, but ask for everything you want, and people should be paid for that, and know your service conditions. If you produce a great spec and you update your specs and you default to 301, you're going to avoid conflicting and confusing requirements by knowing what's in 301. So with that, I'd like to open it up to any questions.
Right. Thank you so much, Michelle. Everyone's giving you a round of applause right now.
So should I stop sharing my screen so that I can see you all?
No, everyone has their video off.
Oh, okay.
So if anyone has any questions, we have the message bar down here in the Teams chat, on meeting chat. So anyone has a specific question, just type that in. Doesn't look like we have any questions right now, Michelle.
Well, that's okay. I know it's lunchtime and a lot to digest. I will say that there's some helpful things in writing for you besides what I covered here. Obviously, I want you to get a copy of 301 for your company, but and I don't make any royalties. It's also, there's a Q&A in Concrete International's October edition that covers the highlights that I just went over. And also the CSI January publication had an article on these changes as well that can give you a nice overview of these changes.
I did have a question on the new modulus requirements, the modulus of
Yeah.
elasticity. You said that's new to ACI 318.19 as well as 301. Just off the top of your head, could you go into a little more specifics of
It's about the testing data being submitted for pre-qualification of the mixture. So that's what's different. I mean, people have obviously designed for modulus long time before 2020. It's just the pre-qualification of the mixture. And then of course there are specs out there that go even higher end and have job site requirements for modulus as well that 301 does not get into.
The galvanized rebar, earlier you talked about that. The changes in that, I mean, there were galvanized requirements specifications before, but
Yep.
a little bit more what has been updated as far as galvanization again?
Sure, it's the difference. There's a 318 specifies one specific galvanized product and used to allow more than that. And since that standard has become very specific to the thickness of the zinc, it's also important. And we talk to reinforcement producers such as CRSI as to what's appropriate for other types of applications, not structural design for 318, but many other types of concrete that is constructed. And there are times that a thinner galvanization would be acceptable for that. So that's the difference between the two standards, is just the thickness requirement. And that was a change in ASTM that 318 was very aware of. And they have a task group just for reinforcement. I think it's B, subcommittee B.
Hey, Bo, this is Jeremy. I can't figure out how to chat a message doing this off my phone here, but I have a question for Michelle. What would you say are some of the most common or typical specification errors or omissions that you've seen, and maybe what do you anticipate to see based on potential changes in the code and the 301 standard?
That is a great question, and due to time, I cut those slides out. I usually give some examples. I think one of the number one errors in specifications is when you reference a document that's not mandatory. So for instance, I've seen really old specifications. I have an example, one from a huge power company that does, decent work, and but it actually says consolidate in accordance with the PCA. And while I'm flattered, I have no idea what that means. We have a consolidation video from the 60s, but that's not going to give you anything that's useful for mandatory requirements. What you need is to write things into mandatory. And then I've also seen specifications that say to construct floors in accordance with ACI 302. That's a guide. I've seen documents that say to use all of ACI's manual of practice. Those are just examples versus not. So that's probably the number one. But I've also seen confusion as to how to interpret, tolerances, or how to decide which number governs. If you have two different documents that are listed in yours, which one's the hierarchy? And many of you as designers know your drawings govern over your, but that it can become very confusing if numbers don't match as well. So those would be the ones that are up for probably the most debate. And that's why you have to look at those open-ended decisions.
Okay. Does anyone else? You can unmute yourself if that's easier. Oh, here's one. Michelle, can you see that? What should an SE be aware of when it comes to tolerances to concrete finishes and flatnesses?
Oh, that's a great question. Now, most of that is actually not specific to 301. If you're aware of design guides, that would be ACI 360 that designs concrete industrial floors. So I would recommend you get involved with, or at least have a copy of that And then on the industrial side, it's telling you to specify what level you need based on, of course, your ride quality. And so the design itself comes from ACI 360, which isn't mentioned in 301, but that would be the default for you for awareness. Tolerances, I mean, those numbers depend on what type of flatness you actually need. I hope that answered your question. Otherwise, I can give you many other documents to reference as well.
Michelle, Jim Tkach, Largo Concrete. I always thought finishes and flatness were referred to in ACI 117.
Oh, yes, I'm sorry. The tolerances are in 117. The design request, so it's whether you're trying to meet a tolerance or you're trying to meet the design requirements for it. So yes, the tolerances are in 117. And one of the only tolerances that isn't covered by 117 that we're very specific on in 301 is a tolerance for welded wire mesh that has not been brought up by 117, but we're working on that. 117 cycle was right behind us and didn't get to that topic before we came out. So, but other than that, yes, you're exactly right. Tolerances are in 117.
Okay, looks like we're wrapping up, but we got a couple more minutes. So one last thing. So you touched on it towards the end, but could you maybe give some recommendations on possibly suggested workflow for someone that's either developing their in-house or updating their in-house specifications, or starting from master spec, and how we would incorporate, you know, the 301 specification. You know, what would be the sort of the workflow and suggestions more specifically on that?
Sure. I do review specs every now and then when I do training for specific companies. And what I would encourage anyone to do is, of course, compare your document to 301 for the content that's in it. You may have, of course, specialized content, but look at your references, make sure they're updated. Standards change on a regular basis, especially ASTM, that's almost annual. Make sure you know what all the default documents have and where your conflicts lie, so that you can choose for your design what numbers matter. That's really important. You know, that guidance can get confusing because you'll have guidance out there on cover requirements. And the reason they're different could be the environment you're building in. San Diego being lovely, but also marine. And then you move around, come here to Chicago, we don't have marine, obviously, but we have quite a bit of salt, and freeze thaw. So there's quite a bit of differences in design requirements based on, of course, exposure. So the main things to be looking at are what you have for reference documents, and then lay out your design based on, you know, the from general requirements to final, and figure out what your special project considerations are, whether it's mass concrete or architectural concrete, and look at all those provisions. And maybe there's something specialized that's not in 301 that you still need information on. The wonderful thing about ACI is that it has a lot of committees and a lot of guidance for you. And you can turn guidance into mandatory language, but you can't just defer to a guide. You have to take the information you want out of it and write it into a mandatory sentence. So that's the important part.
Good. Well, thank you. Anyone else? Well, it looks like that's it, Michelle. Thank you again very much for your time. We really appreciate it. And again, another round of applause for Michelle. And with that, I think we'll wrap up today's meeting.
Well, thank you for having me. You guys have a lovely afternoon.
Okay. Thanks everyone for attending.
Bye now.
Bye.
Thank you.
Thank you. Thank you.